study section 4, Science as a Rational Inquiry. Introduction. In this study section, you will examine the fundamental issues in science as a rational inquiry. To this extent, you will look at the utility of the scientific method. The study section therefore discusses the notion of science, the tenets and goals of science, and a critique of it. It also discusses the objectivity, efficacy, and truthfulness of science, learning outcomes. When you have studied this section, you should be able to point out reasons and grounds for the understanding of science as a rational discourse. Describe the nature of science as an activity that is engaged in search for truth. Notion of science. Let us begin this discussion by looking at the notion of science. Science, as we have come to know it today, is essentially the idea of the founder of the Royal Society of London, 1662, in which Christopher Wren, Robert Boyle were founders. It is a quest and interest in the new philosophy of natural sciences that was then emerging with the experimentations and observation of men like Nicholas Copernicus, Galileo, William Gilbert, and Johannes Kepler. Etymologically, science is a Greek word scientia, which means knowledge, and the German word Wissenschaft, which means systematic organized knowledge. And so, science has been taken to mean knowledge, the synthesis of the systematic study of every aspect of our experience of reality, especially objective reality, usually with the aim of reducing it to a logical, consistent system of order. By this, science is not only a body or a system, it is also a process, the process of gaining knowledge based on repeated observation in controlled conditions, experimentation, and attempting to explain what causes those observations, theorizing through constructing hypotheses that can be tested experimentally. To this extent, science is the study of the natural world through observation, identification, description, experimental investigation, and theoretical explanations. Science, thus, is a way of acquiring knowledge following certain universal methodology whose central theme is the testing of the hypotheses and making predictions for the purpose of a better understanding of the universe. Science, thus, is a way of acquiring knowledge following certain universal methodology whose central theme is the testing of the hypotheses and making predictions for the purpose of a better understanding of the universe. The above definition, meaning of science, lends credence to the basic worldview in science. This worldview involves the fact that A. Science demands evidence. The world is understandable. B. Science is a blend of logic and imagination. C. Science explains and predicts. D. Scientists try to identify and avoid bias. E. Science is not authoritarian, and that F. Scientific knowledge is durable. These features as well lend credence to the distinction that scholars like Melvin Merkin between science and art, religion, philosophy, and other fields. Merkin asserts that science is self-testing, self-correcting, and objective. The import of this is that science is not authoritative. Thus, it becomes obvious that the fundamental reason science seems to differ from other forms of inquiry is its method. This is the method that lays uncanny emphasis on the need and significance of proof, which must involve a conduct of experiment and performance of careful observation. Such method called scientific method involves these steps. 1. Observation. Tentative statement about the natural world leading to deduction that can be tested and verified. 2. Theory. An integrated conceptual framework for reasoning about a class of phenomena which is able to coordinate existing facts and laws and sometimes provide predictions of new ones. Theories explain why laws and facts are true or how they work. Theories are the end point of science. 3. Law. Law in science is statement of an observed regularly among facts, often expressible as a simple mathematical relationship. However, a cursory look at this method reveals not only the strengths in it but also its weaknesses. A good starting point for doing such would be a look at the perceptions of scientific inquiry amidst the question of the possibility truth in observation, fact, which is the bedrock of science. Positivism as a major orientation in science. The positivist conception of science holds as its main position that there are only two types of meaningful statement. These are analytic and systematic proposition. Synthetic statements are true by virtue of experience or verifiability, or a posteriori, while statements are analytic if it is true by virtue of meaning. And any statement that doesn't belong to these categories are nonsensical and meaningless. Example of this are mathematical statements, observational statements, and so on. The patron oracle of positivism, David Hume, writes on relation of ideas and experience that impressional ideas and observational ideas are the only source of genuine knowledge. This approach is what is later tagged verificationism, and it stands in opposition or rejection to all forms of metaphysical knowledge. It buttresses such with the fact that scientific laws that universal and as such pushes science to the objectivist corner of knowledge, thus holding it as the paradigm of genuine knowledge. What are facts? Facts are repeatable observation, experimental event. Facts in philosophy are a state of affairs fact. It is what is observable, and that truth can be known. Truth in science is correspondence to fact. It is worth of note that even the correspondence theory have it that truth are not facts but are correspondence to fact. What makes thus problematic is that the definition itself is circular, and thus by observation in science we mean coming to experience one's environment. The aim of observation is a search for an indubitation truth that will be understood as the external world and how to consistently, critically, and truthfully pursue it. At this junction, the relevant question is the extent to which man is capable of adequate and truthful observation. The one observation that will be free from bias, prejudice, and subjectivity. Observation and the problem of appearance and reality. The problem of how to reconcile the commonsensical view of that our perception gives us the truth with the philosophically eye-opening case of misperception, delusion, illusion, phantasmagoria, etc. For we know that we are often faced with certain objects which when viewed casually seem to be unproblematic, but on a closer look, we discover that our initial perception is not exactly as we had thought them. How do we explain relations between objects in physical objects? This leads to the issue of the observable and the unobservable part of the object. And in fact, why scientists trust microscope as against the naked eyes, this snowballed into the discourse of wave motion, the current of electricity, the atoms, neutron, proton, etc., and all the unobservable architectonics of matter as we deal with in modern physics with their counter and indefinitely unfathomable depth leads to the problem of acquisitive and description. Also is the question of how we can have a direct acquaintance with the object of science data, and when we describe it, are we describing the ephemeral aspect of the object or the substantial? Again, one would question how we have come to the conclusion of having knowledge about this object of knowledge via acquaintance or description. Such questions are important because knowledge episteme an unmistaken awareness of what is presented to us. The last of such questions that make problematic scientific observation is on how we know when we are consenting or dissenting through the testimony of our sense perception and when we are acting from the unconscious assistance of the records of memory. The causes of the obvious inadequate in the reactions of scientists to the about germane questions result in obvious shift in the truth that scientists have given down ages. J.C. Maxwell captures this where he says, the history of restricted to the enumeration of successful investigations. It has to tell of unsuccessful ex-goings and to explain why some ablest of men have failed to find the key to knowledge. The reality of this is obvious of the numerous revolutions and inventions that have taken place within science, from Galileo, Newton to Einstein et al. This, no doubt, is obvious of some inconsistencies found in scientific law and theory. Thus, it becomes pertinent to view science from Popperian angle, verisimilitude, conjectures, and refutations, and indeed, this has expressed Olusegun Oladipo's allusion that philosophy, science, and even art cannot be a search for truth, but an attempt to perpetually have a better understanding of nature and the place of man in it. An appraisal of induction. From the foregoing analysis, it is reasonable to state that science starts with observation. Observation supplies a secure basis upon which scientific knowledge can be built, and scientific knowledge is derived from observation strictly by induction. Induction is the method of reasoning which obtains or discovers general laws from particular facts or examples. It is a production of facts to prove a general statement. However, many have perceived inadequacies in this method. Bertrand Russell has cited this with this story of the inductivist Turkey to show that our knowledge of the past, which scientists work of positivism and inductivism, cannot guarantee our justification in believing that the future will follow after the same pattern. In line with David Hume, Russell holds that inductive principle is incapable of being proved by an appeal to experience. However, Russell argues that induction is indispensable in our scientific inquiry for its high probability status notwithstanding. We must accept the inductive principle on the ground of its intrinsic goodness and forego all justification of our expectations about the future. Any contrary, this lead to the stoppage of all inquiries, and the very hope of existence will also be adversely affected. The import of this is that many like Popper, Kahn, and so on, who have argued against induction are not realistic and sincere enough, because what we called deductive method is a disguised form of induction. However, the emphatic limitation of induction at giving accurate prediction makes the goal of science problematic. In an attempt to unravel such problem on the inductive method of science, in line with T.S. Kahn, Ayo Fadansi has noted that there can be no uniform methodology in the acquisition of knowledge. This allusion gives credence to the impossibility of tiered sciences campaign that employs everyone to think and reason the same way. The disaster such an agenda can pose is what Haken sees when he writes that to compel people to reason in approved ways is to limit us and our potentialities for novelty, science, truth, and philosophy. It is a belief among scientists that their method reveals truth, whereas the question of the constituent of truth is a contestable one. Many have talked about truth from different perspectives. In epistemology today, we talk about truth from correspondence, coherence, pragmatic, reliability, social, practical, and humanist perspective. We even talk of societies, communities as providing the criteria for truth. However, many scientists have heard that truth is a matter of agreement or coherence with other ideas of judgment taken to be acceptable or as corresponding to fact, as we have in correspondence theory of truth. Taking science as a body of knowledge, it becomes obvious it has always been its agenda to unravel the reality of the unfolding truth. But as a matter of fact, science has in many ways taught mankind truth about existence. However, its route to knowledge is nevertheless applicable only to those aspects to natural order which satisfy certain conditions which themselves are not universally agreed upon by scientists and philosophers of science. This lends evidence to the contradiction between science worldview that scientific ideas are subject to change and in fact that science is yet and cannot provide complete answer to all questions, especially the fundamental ones. Study section summary. It is not again saying that science is today seen as the omnipotent of knowledge. The reality of this is based not only on how science has helped mankind in transforming its natural world, and as such seen on how even arts have been compelled to have scientific stature. This extension of it is seen in how science has been extended to investigate other spheres of life, for example, society, man et al. However, fundamental way to understanding of reality is to look at it holistically. This obviously makes us see why the major preoccupations of our time have been to bring different perspectives into synoptic view. Thus, hinging on the shortfall of the scientific methodology and its inability to achieve certain goals and looking at the very fact of some other modes of knowing, it becomes pertinent that intuition, mysticism, and spiritualism has always been and serves not only as complement but also supplement in matter of life where science has failed or has not been able to meet up with the essential challenges. The reality of this is seen in the recent development in sciences that regard practices such as acupuncture et al. As science. The obvious similarities between science and other modes of knowing rest on man's capacity for rationality. It is this capacity that enables man to speculate about the unknown and make predictions. Science does this, and other modes of knowing use it today. This is the end of studies section 4. Thanks for listening.